Well, thank you very much, Stu, for handling the housekeeping for us, and a very warm welcome to everybody joining us on our webinar series today. Like Stu said, we are continuing on our Demystifying Wi-Fi series, and on this episode, we are specifically focusing on how we perform Wi-Fi site surveys. So let's jump straight into it. First off, a quick introduction of who we are. So you've got myself and Mac, we're the Directors of Product Marketing and ECSE over here at Ekahau, and we've got the fabulous Stu, who's just done the amazing housekeeping. He's going to be keeping an eye on the Q&A feature. So any questions that you really want to ask us during the webinar today, please use that functionality. And if you see a question there that you really like the look of that we haven't got around to, use the upvote feature, because that means there's going to be more of a chance that we'll get around to that question during the webinar. So if this is your first webinar that you're joining us with and you don't know what we're talking about when we say this is our Demystifying Wi-Fi series, what do we mean by that? And we mean is that this is the fourth episode of us trying to demystify Wi-Fi. So if you haven't seen the previous episodes, the webinars we've done, we've got blogs, we've got videos and a webinar on each of these categories, and you can access them over at our website at ekahau.com. So if you're confused around, what is coverage planning, or how do you do capacity planning, or planning for the Wi-Fi channels, you can go and check out any one of these episodes to help demystify that part of Wi-Fi.
And the agenda for today's webinar is fairly simple. First, we'll start with what is a site survey. And site survey, my friends, is a visit to the site where you take measurements of something. In Wi-Fi, these measurements are 802.11 modulated things captured by our Wi-Fi cards and spectrum analysis captured by a, surprise, spectrum analyzer, both built into our amazing Sidekick, like a hardware Sidekick, not a Stu Sidekick. Then we'll talk about the different types of Wi-Fi site survey collection modes. And finally, we'll talk about our tips for performing perfect quality site surveys.
And the whole webinar really, focuses on the how we want to get to 3 easy steps to great Wi-Fi every day. And the Wi-Fi site surveys fits into every single one of those categories. So into step 1, when you're validating your design, and you go into your site and you want to take your trusted Ekahau Sidekick, and you can go in, take the measurements of, the wall attenuation, how far your access points cover, the channel contention, what's going on in your environment. So you can go back and validate that your design meets what you were anticipating it to do when you actually get on site. You can use your Sidekick for that, as well as in step 2, also with step 3, when you're performing regular health check surveys, you want to be using your Ekahau Sidekick performing the different types of surveys. And depending on where you are or how you refer to Wi-Fi surveys, people will have one name for how you do a predictive model, or if you do a predictive design, or if you're going on site, are you doing a pre-deployment survey, or if someone just says to you, hey, Mac, or hey, Stu, can you come on site and do a Wi-Fi survey for me? And you're like, sure. Well, what kind of survey is it that you want me to do? Is it a validation survey? Is it an assessment survey? Is it a pre-deployment survey? So we're going to try and put some clarity around the different types of surveys that you do in the different aspects of the Wi-Fi lifecycle, and within our 3 easy steps to great Wi-Fi every day.
And this is the inside look at our amazing Sidekick. And every time I say, or Matt says amazing Sidekick, I can see Stu smiling there. So I'm not sure if you guys seen it before. This is how it looks inside. We have 7 omnidirectional antennas, which means that doesn't matter pretty much how you hold your Sidekick. It will be omnidirectional. It will capture the electromagnetic waves from all the sides. And also it has a spectrum analyzer and 2 great quality Wi-Fi cards. Additionally, we have a hard drive in it, or hard drive SSD, and proper battery with, they say, 8 hours battery life, but actually I've never had less than 8 hours battery life. Typically it's more.
So what are these different types of Wi-Fi surveys that we are referring to then? So if we take a look at our 3 easy steps, are broken down in maybe like a slightly different way, and we take a look at the step 1, and that's the design element of the 3 steps. So that first part is the Wi-Fi design survey. Now this is when you are going to be wanting to go on site to collect the RF and the environment details. So this is when you want to go on site, find out if they've got any interferers, look at where you can and can't mount access points, you know, really start to get an understanding of how the environment is. So then you can go back to your predicted model inside of Ekahau and then update your design. So you go there with your Sidekick, you gather that information, you look at how busy the environment is, how many noisy neighbors there are, and find out, you know, maybe there's some channels that you want to avoid because everyone's just using, let's say, the non-DFS channels on 5 gigahertz. So you think, oh, okay, they're really highly contentious. So I want to maybe use the non-DFS, the Uni 2 extended band so I can avoid some of that channel contention. And you want to go back, get all of that information so you can then go back, update your design. Then moving on to step 2, Mac.
And step 2, actually, when Matt says step 1, sometimes you will start in a different order. So you might be asked to go to the site and do a troubleshooting survey, which is step 3, without designing the network in the first place. Or sometimes you will start with a predictive design, and then you will go to the site to validate your predictive design with Wi-Fi design survey, both part of step 1. And as part of a validation, step 2, we have 2 different types of surveys available for us. First one is a pre-deployment survey. This is a type of survey that you typically do in more challenging environments like warehouses or industrial, difficult to predict open spaces. That's where you use AP on a stick, where after placing an access point somewhere, it's very difficult to come back and change its location for different reasons, like maybe you have access to the ceiling today in a warehouse, then you place an access point, and on the following week, you will have massive racks installed pretty much in front of that AP, and you won't have access to that anymore. So before you do that for 200 APs, for example, you need to make sure that it's absolutely spotless and that your design is really going to work in a real world. That's why AP on a stick is crucial in challenging environments. Not necessarily in carpeted office spaces, typical ones with just like a lift shafts and toilets, concrete core in the center, and open spaces around. In these spaces, it is typically enough to do a Wi-Fi design survey followed by a Wi-Fi design without doing AP on a stick. Additionally, when you do AP on a stick survey, it doesn't mean that you have to do a mini survey around AP on a stick. By the way, we will talk about the AP on a stick in more detail later on. It means that you have to just do it enough times for you to fully understand the propagation of radio waves around you, so you validate your design. So that's pre-deployment survey. And then you do your deployment, all the access points and fancy antennas, they are placed, mounted, tilted, directed, exactly as you said they should be in your fancy predictive design. Then you do a post-validation survey. And you do a post-validation survey at least a few days after the deployment was finished, because you want to make sure that your RRM algorithms, radio resource management algorithms, different vendors will call it by different names, but channels allocation, transmitting power level, they will need time for the vendor to settle on optimal settings. That's why you don't do post-deployment survey on the same day as your deployment. There are a few more, I think, very good tips for post-deployment surveys that we have for you here. When you do a post-deployment survey that validates that everything that you scoped as part of your design is really working as it should in the real world, freeze that channels and transmitting power levels before you start doing the survey. It's very, very frequent that some channels change while you are walking around. Transmitting power levels change while you are walking around, and then you end up having access points with the radios transmitting on 4 different channels on 5 gigahertz, and then you scratch your head thinking, what the hell happened? So freeze that stuff. And that's post-deployment survey. And Matthew, I think we'll go back to you for step 3.
Thanks, Mac. There are some really good tips to think about then for when you are doing your post-deployment validation survey, is letting the RRM algorithm settle down and then freezing that RRM algorithm so that your channels and transmit power are not constantly changing whilst you're performing a validation survey. Because if that's happening, it's almost like the goalposts are moving every time you're walking around collecting that data, because everything's changing. The channels are changing, the transmit power changing. So the coverage is going to look different. The channel interference is going to look different. So great tip there. So if we take a look at step 3 of the health checks element to our 3 steps to great Wi-Fi every day, we kind of broken this down to the periodic health survey and the troubleshooting assessment survey. Because like Max said, you may get called in to do a survey because the people are having problems. And then when you start to speak to your stakeholder that's asked you to come and do the survey, you actually find out it's because they're having some issues with the Wi-Fi that's already been deployed. So they want you to come and do an assessment of that environment. But one of the most overlooked surveys, I think, especially when we was doing professional services, was the periodic health survey. Now, a lot of our customers or stakeholders, they just didn't see the value in this. They didn't think it would be worth paying that additional money for. But if you do not perform these periodic health check surveys, there's no way you can keep your finger on the pulse of your Wi-Fi network and find out what is happening and then fixing those issues before they become too apparent and the Wi-Fi goes down and it stops working and now you can't run your business because you wasn't adaptive and constantly checking your environment. So this is why it's super critical to constantly do these periodic health check surveys, because so much changes in Wi-Fi. You could have done your amazing design, you could have done your perfect deployment and validated it. And then 3 months later, they've had physical changes in the environment. They have more users coming in. They use the Wi-Fi in a different way. They've had firmware updates happen to the printers and the TVs and other devices around the office. And now they're creating tons of channel contention. The environment has changed. So you need to go there, check what's going on, and then you can be adaptive to make sure that you constantly keep a high performing wireless network. And then the troubleshooting assessment survey is when you've had a design done by someone else and it's been deployed, and then a few weeks, months, years later down the line, they're trying to use the Wi-Fi and it's just not working in the way that they intended it to, whether it's in a warehouse, whether it's in an office or a shopping mall, and they call you to come out and do an assessment survey to find out what's going on. So this is when you would start at step 3, you would do an assessment and you would see, you know what, this design was done 5 years ago for providing basic Wi-Fi connectivity, but the way that you're trying to use the Wi-Fi today is you want to run voice and video calls and run your business over the Wi-Fi, whereas before you had all of these cables everywhere that people were plugging into. Well, you know what, you need to do that's a complete redesign. So you start at step 3, then you go back down to step 1, and then you start with a new design. Then you move on to step 2 to validate that design with either a pre-deployment survey and then finally a post-deployment survey. So hopefully that's given a little bit of color around the different types of surveys, because I'm sure everyone on the webinar today at some point in their life has been asked to go and do a survey. Hey, can you go do a survey of this environment? And, you know, we all say, yeah, of course, but what kind of survey? So yeah, there we go.
And these steps are really key, folks. I mean, what Matt and Matt are talking about here is where we want to understand, you know, we've gone through that whole life cycle, that design and validate health checks. And again, health checks are definitely something you want to keep an eye on, because a lot of times you can come into a warehouse. I know, Mac, you and we've seen this where you've gone into a warehouse, the complaint is not working, but the NMS software, the dashboard says, yes, it's working fine. Clients are connecting, but they keep dropping off. We're not too sure. You go to the warehouse and physically look and you see, well, as part of that health check, you're going to visually look, right? Well, someone's damaged the antenna. It's knocked out of place. One of them is off. You got 4 and 3 of them are out, or something because a forklift hit or something, a box hit or something like that. And a lot of times it is, you know, those are things that you can use as a visual on your health check to go and check that out. Add that into your document as well by using our trusty iOS type survey. Take a picture of it, make a remediation plan for yourself.
Yeah, we say that a lot about, you know, warehouses and antennas being moved by forklifts, but it honestly happens more often than you think, because forklift drivers, it's not necessarily the most obvious thing they're going to see as they're driving around. They're looking for the pallets, where to go, and they whack an antenna and it changes the orientation of that antenna, where it's going to affect the propagation pattern. That now means that the coverage that you used to have down that aisle is now gone. So when they're trying to do the scanning of the inventory and the stock, it's no longer working. But what do the users say is that, hey, the Wi-Fi sucks.
Right.
So,
or someone's put in a giant fan in the warehouse and it's actually called a big ass fan. That's the name of the company. and it's so massive that when the fan spins, the blades kick in, right? And that attenuation of that Wi-Fi is going all over the place, right? It's having a nice dance. So if think of your APs going around and around, right? So that does happen, and those things get installed after your wonderful deployment. You've done all that hard work.
I feel like I have to share a story, Mac, of something that actually happened to us. And that was, we did a design for a warehouse, and we did the design, the deployment, validated it, and it was all working perfectly. It had lots of racks. We put access points down each aisle and with the antennas and stuff. And then literally like a couple of weeks later, they called us back and said, hey, the Wi-Fi isn't working anymore. And we were like, what do you mean? Why is the Wi-Fi not working anymore? And I said, yeah, look, I said, we said, has anything changed? I said, no, nothing's changed. The Wi-Fi just stopped working. And of course, me and Mac, we got in our car, we drove to the site, we went on site, and what did we find? Well, the back wall where we had mounted the access points and antennas, they had decided that there was now enough space to put a rack against the back wall so they could fit more stock on there. So they had built another rack in front of all the access points and antennas, and then filled it with stock, which was covering that, where the access points and antennas were covering the aisles. Well, now they were completely blocked by this new rack that wasn't there, like literally 2 weeks ago, and it was completely filled with stock. Because we went, well, yeah, I mean, you blocked the Wi-Fi, so what do you expect? And so these things, they do genuinely happen. But anyway, let's take a look at what we got coming up next. And we have our first poll question.
And I will be super delighted to read the poll question for you. When performing a pre-deployment validation Wi-Fi survey, which do you find the most important? A. Wall attenuation values. B. Signal propagation to understand coverage. C. Signal propagation to understand contention. D. All of the above. Or E. I do not do pre-deployment validation Wi-Fi surveys. And just a quick reminder, a pre-deployment validation survey is an AP on a stick survey.
Yep. We will let the poll carry on running for a few more seconds whilst you are voting. Please.
I am running.
Doesn't look like you're running. But yeah, we'll let it go for a few more seconds, and I will end the poll and share the results with everybody now. So let's share these results, and we can see that big percentage of you went for all of the above. So checking for the wall attenuation values, the signal propagation to understand coverage, as well as contention. So that is really, really good. But very interesting to see that there's still a percentage of people that do not do pre-deployment validation Wi-Fi surveys, so AP on a stick type of surveys. I would be interested to find out why that is. So if that was you that answered that, please drop a message in the chat and let us know.
Exactly. And I'm really proud of you, everyone, because I was looking forward to all of the above answer. That's probably the right answer. However, if you don't do pre-deployment surveys, we understand, we don't judge. You might be working in environments that do not require those surveys.
And hopefully after this webinar, we can actually probably put some value to that, right? And here we are. Speaking of which,
here we are. It was like we knew. So for people that are joining us on this webinar today who are not familiar with what an AP on a stick is, well, if you see behind me, I've got here's one I made earlier. That is behind me as well. You can just about see my AP on a stick set up.
I really like your hand movement. It's like so smooth.
Don't get too excited, Mac. And we are going to just explain a little bit what an AP on a stick type of survey is. So this is when you want to take the actual access point model and antenna that you're planning to deploy on site that you are using in your predictive model, but maybe it's a slightly challenging environment. Perhaps it's an environment where you just want to validate that when it does get deployed, it's actually going to definitely match what you've got in your predictive model. So what you do is you take that access point, you mount it on a tripod, that's what we call the stick. And then what you're going to do is you're going to have a battery pack to power that access point, and then you're going to turn it on. And then you're going to configure yourself a couple of SSIDs. And what we've got here is an Ekahau survey SSID on 2.4 gigahertz on channel 1, then an Ekahau survey 5 gigahertz on channel 36. So it's just broadcasting the two channels. You're going to set the transmit power to be static. And then what you're going to do is you're going to plop that AP on a stick in one of those positions that you've got your predictive model for where you want to place it, an access point. And then what you're going to do is you're going to take your mobile device or your server device that you're using with your trusted Ekahau Sidekick. And then what you're going to do is you're going to walk a distance away from that access point to measure how far it actually covers. And then we've got two values here. And you can see we've got the guy with the cap on walking to the cell edge of neg 67. And then we've got the lady with the cap on walking to the cell edge of minus 85 dBm. Now, let us know in the chat, when you're doing a pre-deployment AP on a stick type survey, what value do you usually walk to? Is it the neg 67 dBm value, or do you walk to the neg 85 dBm value when you're performing your pre-deployment validation AP on a stick type surveys? Let us know, or if it's something else, you can tell us it's something else. But I'll give it a few seconds, then I'll let Mac explain what we're talking about with these values here. Let me just open up the chat.
You can see the values are just going like crazy here. This is good. Yes. A lot of audience participation here. This is great.
Wow.
What do you say, Stu? Do we have like 50-50 between neg 67 and...
It's like reading the time zones, right? Yes, I think we're pretty much right in that middle, right? It depends.
Yeah, that's why I'm asking. Actually, I think neg 67 is kind of winning here versus neg 85. So guys, neg 85-ish, around that. We have two values in Wi-Fi in 802.11 that we really care about. First is the preamble detect, signal detect, which is 4 dBs above the noise floor. So if a Wi-Fi station hears another Wi-Fi station with 4 dBs higher than the noise floor, they will be able to demodulate a preamble, and they will defer from transferring data even if it's their turn to transfer. So that's what a CCI is pretty much. When we have multiple clients trying to access the medium on the same channel and they can hear each other very faintly, they will still politely wait for other clients to finish their transmissions. That is why we think that in most situations, surveying with AP on a stick until you get to the threshold of around neg 85, which happens to be around 4 dB above the noise floor, makes sense. Because if you do that, then you understand how your APs are going to be creating contention with other APs around them. If you just survey to neg 67, then you are validating your primary signal strength in typical environment. Sometimes it will be neg 65, sometimes it's enough to design for neg 70 from free space pathless perspective. But in most cases, we really want to understand what channel contention is going to be, hence around neg 85 threshold.
Great explanation.
Thank you very much, my love.
There is something else that we needed to talk about when you are doing an AP on a stick or a pre-deployment validation survey, and that is something that's called freezing your AP. So if you're performing this type of survey with Ekahau, then that means that what you need to do is, once you've collected that information, that data, you need to tell Ekahau that you want to freeze that access point's data, so you can then pick it up and move it to a new location. And then when you survey that other location, in that other location, it's stored the details for where you surveyed originally on that position, and then it will create the new data for the new access point. So it's really important to remember to freeze your APs. That's why you can see on the left-hand side, that middle AP icon has got like a snowflake icon. The other thing that we want to talk about is locking your channels. If I just go back one slide, you'll see that our test AP here, the pre-deployment AP on a stick that we're using, is just broadcasting on channel 1 and channel 36. So why is that important? Because by default, the Sidekick is going to be scanning all of the channels. But if you are focusing on just the AP on your AP on a stick to get that data, what you can do is tell the Sidekick to only scan on those 2 channels. And what that's going to do is it's going to create more data points on your survey path, so you can get lots of data and information about your test AP, if that's all that you're interested in. So on the left-hand side, we locked onto just the 2 channels, whereas on the right-hand side, that's when it's scanning all channels. And you can clearly see here on the survey path, there are way more blue data points. Anything you want to add here, Mac?
I'm typing answers to questions in chat, so no.
Okay, fine. So yes, and there may be an argument to say that even if you are doing an AP on a stick type of survey, that you may still want to scan all of the channels, so then you get a good understanding of what's going on in the environment. And Mac, we can hear you typing now, thanks. So we can, if you have all of this channels enabled to scan when you're doing your AP on a stick type survey, you get to build a picture for the environment, so what's happening on all the other channels around you. But if you really only care about your AP on a stick, then you can just lock on just those 2 channels, but be aware that you're not going to be collecting the data for those other channels.
But this is, I mean, that is literally important, right? Is to do this, because this is where you're literally telling that Sidekick to put its resources and just focus on that, right?
Yeah.
And that helps, because it gives you that true painted RF picture of what's happening. And both are correct, but both are, they serve their purpose for each one. So
exactly. So it really depends on what it is that you're trying to look for, or you're trying to get from your type of survey. The good thing here is that the options are available for what it is that you're looking for to do. So we're now going to talk about the different types of survey data collection for using either our mobile applications, or if you are still using a laptop. So what are these different types of survey collection methods that we can do? So what we can see here is we've got a really cool dude with his mobile device connected to his Sidekick. And the first method that we're going to be talking about is the stop and go type of survey mode. So if you've ever used the Ekahau application before and you're performing a survey, you have an option to choose a different type of survey method. So stop and go. Now, when would we recommend that we do a stop and go type of survey? This is typically when you're going to be in maybe more challenging, maybe harsher environments, because what you do is you basically go to a position on the floor plan where you are in the environment, and then you tap on the screen of your mobile device, or you click with your mouse if you're using a laptop, and it will basically count down for a period of time. Default is 5 seconds, and it's going to be collecting the information about the Wi-Fi for 5 seconds in that position that you're standing in. You can change that time if you want to, but then once it's finished that countdown, until you move to the next location and then you click again, it is not collecting any of the layer 2 Wi-Fi information. So all of that data from when you walk from point A to point B and you clicked again is basically not being collected. So it doesn't collect as much data if you use the stop and go method, but if you are in certain environments, then there is a use case to use it there. If you're, I don't know, there's lots of stuff flying around, moving around, or you got treacherous terrain and you need to really watch where you're going. You might just want to go to that position, click on just stop and go, and you go, okay, I need to climb out of here, or swiftly move over there, or dodge a forklift there or something, and then you click in another position. So that's the stop and go method. You can use it probably in more dangerous and hazardous environments. So Mac, I'll let you talk about the continuous mode.
Of course, and I think you can use continuous instead of stop and go as well. So even if you are in a very difficult environment where you constantly have to watch for hazards, you can still use continuous and do like a mini survey without moving around too much. Probably you will capture more information in the same time when compared to using stop and go. That's why I personally call stop and go a legacy mode. However, it's nothing wrong with using it. It works for as long as you understand that it just captures data for a few seconds and then it stops capturing data when you're not clicking and waiting, then you're good to go. So continuous mode is the most classic mode that we have at our disposal. What it means is you continuously are scanning channels while walking around your premise. So when you click first, when you start your survey, and then you move to your next location, while you're moving, your Sidekick is constantly capturing data in the background. And depending on how many channels you are scanning, it will take a second or 2 seconds, not more than that, because we have in 2.4 and 5 gigs, 39-ish channels, depending on regulatory domain that you're in. And even if you're scanning all of them, the dwell time on every single channel is 105 milliseconds, and we have 2 wireless NICs inside a Sidekick. So if they are scanning different sets of channels, and by default they do scan different sets of channels, you will be having like around 2 seconds scanning time until you scan all of the channels. So when it takes you like 8 seconds to move from point A to point B, for example, you will have scanned entire spectrum 4 times or more. And then when you click on your second location, your full scans will be dropped across the route that you've taken. It will be spread equally. And then you continue walking around. So I would say that continuous mode, if you are accurate, if you have good attention to details, if you have good quality floor plans that are scaled correctly, it can be extremely accurate. The only challenge with continuous mode might be when you are in an environment where you don't have too many reference points around you. So if you don't know exactly while looking at the map where you are, then continuous mode might be a little bit challenging. And in this situation, different version, different type of survey mode, capturing mode, might be a better suitable. And that leads us to an autopilot.
Yeah, and I am excited because I get to talk to you about the autopilot survey mode, which blew my mind when Ekahau came out with this type of survey method, and I started to use it in the real world. So just to recap then, the previous two survey modes, continuous and stop and go, they both require you telling the application where you are on the map at that time. Autopilot uses the built-in AR kit on your iOS devices. You basically give it an initial calibration points to say where you are, and then you walk for a period of distance. And a tip here is to try and give it as big of a distance as possible. And then once you've tapped again for the next time, it's hands-free and the device knows where you are. It's so cool. Like you can see the dude on the screen right now with the icon, and then they're kind of showing the direction that he's walking. And we've got a video that we're going to play you straight after this slide to show you it live in action. And you can just walk around with your mobile device if you want to just have it in your palm of your hand. I like to do it with an iPad, which you'll see in a second. Once you've gained that point, you just walk around and there's no need to tap on the floor plan on the application anymore. Sometimes you may need to correct it if it does like go to veer off at some point. You may need to tap, but it's literally, if you were tapping 10 times for a continuous, then it would be once for autopilot. So it's much more hands off, and you can walk around, you can capture data so much faster, and you can be way more aware of your surroundings. And especially like Max said as well, if you've not got many reference points, we surveyed like a 720,000 square foot warehouse, both of us at the same time, using the iPad and Sidekick and autopilot mode, and we didn't barely have to recalibrate the path at all. And we've done it in offices, warehouses, outdoors, and it's just unbelievably good. So I'm really excited to show you the video of it in action. We're going to talk you through some tips and stuff that we do to make it work as best as possible, as once Mac has told you about the GPS.
Go for it. So Matt is okay. I will tell you about the GPS first, then when Matt is looking for a file to share with you. So GPS mode, it works on mobile devices that are equipped with GPS radio. So if you have a SIM equipped version of an iPad, for example, or if you are surveying with an iPhone, then you can use a GPS that is built into your device. So it will be pretty accurate. GPS accuracy in your mobile device will be around 1 to 3 meters, typically. Sometimes less, sometimes more, depending on the environment you're in and depending on the number of satellites you're logged into. But if you're surveying vast open spaces, mines, deserts for some reason, or big campuses that don't have too many reference points, and you are outside, or if you're doing a city that doesn't block your access to satellites, so you can have GPS log, then there is nothing wrong with using GPS. In the past, we were using a dongle with Windows laptop GPS dongle that you could use outside as well, but I wouldn't say there is any use case for that now when you can just hook it up into your mobile device and use that instead.
I say, so I have the video now and I will play it, and then let me just talk you through what is happening. So you can see now I've got the iPad. I've just clicked on the screen. It says that's my first reference point. And then what I do now is I walk as far along this wall as possible before I click again on the map. So I've tapped again and you see, woohoo, live location. And now what you can see is me walking around and then my survey path being updated for me without me touching my iPad at all. So it's just moving automatically for me. And I've put my pencil back on top of my iPad now, and I'm just holding my iPad in front of me and I'm just walking around. I had some weird guy that was filming me as I was doing it for some reason. Clue here, he's got curly hair.
Who was that guy?
Yeah.
Who was that guy?
follows me around everywhere. It was quite dangerous as well because I nearly got shot by like a bow and arrow at one point as well. I'm not sure if you saw good old Lara over there nearly got me. And there's another guy here. He had an axe, but luckily there was a monkey head on it to protect me from that. But again, at no point have I touched my screen now to update where I am on the floor plan in the office. I am just walking around, walking. And then I just finished. So we surveyed the whole office just by using Autopilot. It's by far our go-to survey mode. We absolutely love it. It's so much faster. It gives you more awareness of your surroundings, and it's just really, really cool to use. I'm not gonna lie, I love using it. I think it's great. So the big tip here, though, to get the best accuracy and the best outcome from when you are doing it, you really need to make sure you've got good floor plans. That definitely helps. The next key thing is in making sure that you've accurately scaled those floor plans. I can't emphasize that enough. Scaling is pretty much one of the most important things that you do when it comes to anything Ekahau or Wi-Fi related, because everything in Wi-Fi is all distance related. Then my next tip here is that you want to, when you're setting those first initial calibration points, is try and give it as big of a distance as possible. And of course, make sure you're accurately tapping on the application where you are. If you don't tap in the right place, then yes, it's not going to be accurate. So remember that junk in, junk out. So my three big points that I want to just emphasize there: good floor plans, scale it properly, and then give biggest possible reference points for those two calibration points is going to set you up for success for when you perform autopilot surveys.
I have one more tip, important one. So a nature of the AR kit is that after some time, because it's not perfect, it's using dead reckoning. So after the first initial calibration, your device, it knows where it is. Well, it doesn't know where it is, but it knows your pace. It knows your, it uses a gyro accelerometer. So when you speed up or slow down, it knows about it. When you move to the left or to the right, it knows about it, but it won't be perfect. So after some time, there is a chance that it will start to sway away from your path. And if you see that happening, don't panic, just look at the map, at where you are, look at the real location of where you are, and move to the nearest point that you can locate on the map and click extremely accurately where you are. It will recalibrate your AR kit, and after you clicked extremely accurately, it will be amazing again. What I've noticed is that people, they put quite a lot of details into the initial calibration, but not into recalibrating it after it starts to sway away from your path. You need to be equally accurate, both initially and during the survey. Sometimes you don't have to do it. We've done like 2 kilometers walks where we didn't have to recalibrate it once. It was still like plus minus, let's say 20 centimeters. But sometimes if you have changing light conditions, if someone walks in front of you and, you know, AR kit just loses its mind, you will probably have to recalibrate that stuff. Just do it.
And one thing to keep in mind on that is you've got your iPad or iPhone. Many of us have cases or something around it. Don't block the camera, because that's really important. And the
yes,
camera is actually taking the measurement on the floor, right? So
true. Guys, few comments on the chat. You can do autopilot on all Apple devices. You don't need to have LiDAR equipped devices or Wi-Fi only devices. That's not the case. If you have LiDAR, it will be more accurate than just the camera, but you can still do it with just the camera with no LiDAR, and it's fine. It's fine. Yeah. And also, you don't have to stop or restart the survey to recalibrate it. You do it as you go. As soon as you realize that you're starting to go off, stop, think, click accurately, and life is good again.
Yep.
Yeah, for sure.
Okay, so one of the other things as well that used to be slightly challenging for me to get my head around was when people were talking about, you know, what can you go and do a passive site survey, or can you go do an active site survey, and what is the difference? So we want to try and demystify that for you right now. So what is a passive site survey? And this is when you are using a device to just passively collect the information being sent over the air. So things like the SSID, the signal to noise ratio, what physical amendment we're using, the security, the signal strength, all of that information is being captured by the Sidekick. It's listening to what's called as beacon frames and probe response frames. But the Ekahau Sidekick, it never associates ever to a Wi-Fi network. The Ekahau Sidekick is a passive only device. Whereas if you are doing what is something that's called an active site survey, an active site survey is when you are connected to the Wi-Fi as you are performing your Wi-Fi validation survey, troubleshooting survey, assessment survey, but you are then collecting more information at the higher layers. So passive site survey is just collecting information at layer 1, layer 2. An active site survey is collecting data at the upper layers. So we're doing things that if you're pinging the default gateway, or if you're pinging maybe Google DNS and you are looking at the round trip times and the packet loss, that is going to be being done from the perspective of your survey device's wireless NIC card. So if you're using an iPhone, it'd be your iPhone. If it was your iPad, it'd be your iPad. If you're using your Windows laptop, it'd be your Windows laptop. Another type of active survey is when you are actively transmitting data to a server, so like an iPerf server, an ePerf server, and this is when you're going to get the information of things like throughput and jitter. So you're actually transferring data over the air to the access point, through the access point, the cable to the switch, through the firewall to that endpoint device that you are running those tests to, and then you are actually going to see how that Wi-Fi device is performing in that specific location at that moment in time. And you can see the actual data rate and the throughput that it's actually been able to achieve. But it's really key, and it's really, 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 really important that we understand that all of this information is always from the perspective of the Wi-Fi device that you're performing the survey with. And why is that important? It's because let's say that you are performing a Wi-Fi survey at your local school, but you are using the latest and greatest iPad. But the school, they're not going to be using iPads, they're using Chromebooks. So how your iPad performs on the Wi-Fi is going to be completely different to how that Chromebook performs on the Wi-Fi. So if you're doing an active survey with the iPad and you want to show that data to the customer or the stakeholder, whoever's asked you to do that survey, and they look at it and they go, oh, that looks green, fantastic, amazing. But then they do the same test with the Chromebook, it would look completely different because they're completely different devices. So we're actually going to give you a demo now, a live demo of a active survey that was done. So I'm going to stop sharing, let Mac take over, and we're going to show you the reason why it's important that you understand what it is you're looking at when you're doing an active site survey.
Hopefully you can see that nicely and clearly. I'll move all the stuff away from my screen. So guys, what you can see here is a small school with a very decent design for 5 gigahertz. And all the access points, they are set to 5 gigs. Some of them, they are set to 2.4. And as you can see here, like the signal strength is totally spotless here. And let me put the scale up. It's NEC 67 or stronger everywhere. Secondary signal strength for roaming is amazing as well. Let's take a look at channel interference, and channel interference is non-existent. We have 1 CCI everywhere, and it's absolutely spotless. So from our Wi-Fi pros perspective, the Wi-Fi is amazing. And now Fernie, when he was walking around, he was using an old survey device. It might have been, or it must have been, one spatial stream N or AC device with a maximum data rate of 86 or something megs per second in current conditions and on 20 megahertz channels. So we would expect a throughput, because that's the type of the active survey he was doing, to be peaking at around 50 megs per second. That's what I would expect if I was standing next to the access point with no interference whatsoever. So let's take a look. Here is the blue dot, and this blue dot represents Fernie and his device. And here is a slider that we can use to reproduce the route that Fernie has taken while walking around the school. So he's here, and when I'm moving the slider around to the right hand side, I can see that he has moved here to room 126, and now he has moved to the adjacent room, and then he starts going down, and he moved into room 124, then starts moving down, and then he gets to the corner, he goes behind the corner, and then he walks into rooms on the bottom part close to the access point on channel 157 and 100. So we understand the survey that he's taken. He started here and then went down, walking into every single room. So now try to imagine a scenario where you have a school that has paid $1 million for a new Wi-Fi deployment, and then you have a school principal working together with you when you're doing a post-deployment Wi-Fi survey, validating the deployment, the new deployment. So the guy is very proud of this network. You're very proud of your work. You've designed it so your voice and video applications, they should work spotlessly. And then you've decided to do an active throughput test. So you started walking around, and when you started here, you're standing very close to the access point, and you can see that the throughput is close to 50 megs per second. So life is good, everything is fine. Then you start moving down, and when you start moving down farther away from the AP, the throughput goes down to 28 megs per second, because now the signal has to travel through 2 or 3 walls. Then you disappear behind the corner, and you can see that the throughput has dropped to 17.7 megs. So it is dropping down quite dramatically, and then you're in a room that has its own AP on channel 52, but the throughput, it's not 50 megs again, it's down to 16.6. So Fernie continues walking down, and he gets to around here, and we can see on the left hand side that something has changed. He is indeed roaming from the access point that has a MAC address, BSSID, so the MAC address of the radio Fernie is associated to, ending with EB2C. I put it here in a quick, not quick select, in a find window, and it's highlighted the AP on channel 108. Now, the second AP that he's going to jump to is what? So what do you think? What access point he would connect whilst he is around here? Would it be an AP on channel 52 or 36 on Wi-Fi 7 or 157? Let's take a look. So I will quickly put D8 6C here, and I can already see that Fernie has now connected to the access point on channel 52, because when he was passing next to the AP, his survey device has decided to join that AP, and then he continues moving down. He will go to rooms 157, 100 with access points on channels 157 and 100. Let's take a look at the throughput. So now I have a heat map with throughput in front of us, and it's got red here, so the throughput has dropped down, and we know that's because of he roamed to a different AP, but it didn't recover fully. It's not light green again, it's darkish green. So even if he's like close to the AP, he goes behind the corner, he now has half of its maximum data, of its maximum throughput, real throughput. So do we have problems in, let's say, room 120 or room 121? We can see that it's red. It's red here. Does it mean that we have slow Wi-Fi in that room? Let's take a look. So when I hover over this room here, it's 14.7. Here, just next to the AP on channel 100, I have 5.1 megs per second. But whilst I'm standing here, I am still associated to the AP on channel 52. So let me move back a little bit. I was associated to that AP. I moved into that room, into that room, that room, that room. So Fernie has passed next to at least 3 better APs until he has made a decision to connect to the access point on channel in this room, not 100, but to the access point 2 rooms away on channel 157. And is this wrong? It's not wrong. It's absolutely normal. That's how Wi-Fi works. The roaming decisions are being made by a Wi-Fi client using a firmware that is running on a Wi-Fi card. We call that firmware, we call that decision-making a green diamond algorithm, and every device will be different. MacBook will be slower to roam because it's not designed for fast roaming. iPhone or Android handset, it will be roaming faster because they are mobile devices designed for fast roaming. So for as long as we understand that this is absolutely normal, like drop in the throughput when we move away from the AP, then we can do active tests like a throughput test. But if we don't get it, then we can have angry clients shouting at us that their network sucks, when in the real world it might be spotless. Because if you grab a phone that connects to this Wi-Fi network and you move around the school on a voice call, it might work just fine. You don't need to have massive throughput for a voice call. And if that was a purpose for your Wi-Fi network, then life is good. You don't need to have consistently high throughput. And that's pretty much everything that I wanted to talk about here. I will stop sharing. Matt, do you anything to add?
No, that was great. We've got a webinar
really good
poll question to Fire up. A fantastic demo as always. So Mac, if you would like to read it out, I will launch it for us.
I will be absolutely delighted to read it out. So the question is, how has Ekahau improved the way you do Wi-Fi site surveys? And the answers are, I save so much time performing Wi-Fi surveys. B, I do more surveys and make more money. C, I no longer worry about getting hit by a forklift truck. D, I'm not getting interrupted by people asking me if I'm ghost busting or selling ice cream. Or E, I'm not an Ekahau customer yet.
Really looking forward to seeing the answers to this poll coming in, and we'll give it just a few more seconds to let it carry on running. And by the way, just to announce something, people on the webinar, make sure you stay to the end of the webinar today. We've got a little bit more content to get through, then we've got a very big special announcement to share with you. So make sure you don't drop off early today. And that being said, I will end this poll now and share the results with you. So it seems like the vast majority when we answer A, which is that you save so much time performing site surveys now, thanks to Ekahau and the Sidekick. And this was really, really true for myself and Mac when we got our hands on the Ekahau Sidekick plus the mobile devices. So no longer having to wear those survey trays and placing the laptops with all of these dongles. The Sidekick doesn't drain power from your laptop. You can walk faster, you can moonwalk, you can run, you can do whatever you want with the Sidekick pretty much. And you haven't got to worry about bashing into doors or having the power drained from your survey device.
I remember the days where the recommendation was to take 1 step per second if you had like one dongle scanning all the channels for you, because the scanning time would be more than 4 seconds now, and you indeed have to be walking very, very slowly. There is like more good answers there. I do more surveys and make more money, and that's exactly the case as well. It was the case for us, for me and Matt, because we were using Ekahau to do a customized automatic reporting that saved us few hours every single time we were doing either survey or a design, because you can take pretty much all the information you want from Ekahau and put it into the report. That's it.
Yep. And we have something free for all of you as well, which you will be receiving into your inbox after this webinar. The thank you for attending. It's going to be our 6 tips for super accurate Wi-Fi site survey. So we're just going to quickly run through what these 6 tips are. So first of all, like I mentioned before, scaling your floor plan is so crucial. The common thing that we see people do is that they would just get the floor plan, load it in, and then they will scale a door at 1 meter. But what happens if that measurement there is off by 20 centimeters and it's actually 0.8 meters? Well, you think 20 centimeters doesn't sound that big of a deal, Matt, but when you magnify that over a floor plan that's 100 meters, 20 centimeters turns into 20 meters. So that's a massive difference. So make sure you scale your floor plan accurately, because everything that you do in Ekahau and Wi-Fi is distance related. Your designs, your validations, everything. So scale is number 1.
And number 2 is to use your beloved Ekahau Sidekick, because Ekahau Sidekick is a measurement device, purpose-made measurement device made for capturing data, Wi-Fi data and spectrum analysis that can affect Wi-Fi transmissions. So use that Sidekick. It's fast, it's accurate, and it's software calibrated. So every time you use your Sidekick for your surveys, for your validations, your results will be very good.
Yep. And then making sure that you scan the proper channels. So if you're in an environment where you don't necessarily need to worry about 2.4 gigahertz, you're not validating it, you're not designing for it, you don't care about it, what you can do is you could disable those 2.4 gigahertz channels, and then you can just focus the Sidekick on the 5 gigahertz, therefore collecting more data samples. Or if you're doing a pre-deployment AP on a stick type of survey and you only care about those 2 channels, lock the Sidekick onto those channels if that's what you want to do.
And then 4, capture accurately, and that's extremely important. Pretty much I think like together with the scale and a good quality floor plan, it's the most important, because when you click where you are, it's fine. But when you click when you're going to be in 5 seconds, it's not fine anymore. So don't go through the walls, don't go through the water, don't fly through the window. Just click where you are, and then your survey results will be spotless, especially when, let's say, you're clicking inaccurately and you went through the middle of the fountain. Your clients can ask, can you walk on water? And if they do that, your credibility is dead.
We've seen some people turn into Superman when they fly out of one window through one building into another one. You think, wow, how did they manage to do that? But that's the thing, Ekahau doesn't understand or know. So please make sure you capture accurately. And the other thing we want to mention here is that number 5 is make sure you walk on both sides. Walking on both sides, what you care about. If you want to understand that wall attenuation value of a specific wall, you can't just walk on one side of it to understand it. You need to go on both sides. So whatever it is that you're measuring, make sure you go on both sides to capture that information. And then the final one is number 6 is using the correct survey method for your environment. So depending on where you are or what type of environment that you're in, you're going to want to use a different type of survey mode. So we went through the different types of survey modes earlier, so we won't run through them again. You can read them at your own leisure once you get this in your inbox. And finally, the big news, the big announcement is that we have got a product launch. We are unbelievably excited. The hairs on the back of my neck have just gone up by even just showing you this, because it's something everyone at Ekahau has been working so hard about, and we cannot wait to talk to you about what it is. And we are telling you way in advance this time to make sure you lock that time in your calendars, in your diaries, because you're not going to want to miss this event. It's on May the 19th. You can just scan that barcode, go and get yourself registered, because it's our biggest ever software innovation. And there's a bit of a clue potentially in there, which I won't point out. It took me a while.
It's not a clue, it's a typo.
It's a typo. Okay, sorry. It's a typo. It's a clue. Who knows what it is? To find out what it is, make sure you register and make sure you come and join us on May 19th. We're going to have an action-packed webinar. It's going to be full of live demos. All of the product team. Yeah, it's going to be unbelievably amazing, and we are so excited to share with you what it is. So please make sure you scan that QR code, get yourself registered. You're not going to want to miss it. Oh, I need to take a breath. I'm so excited. I'm like, whew.
I think we'll all be tired because I won't be able to sleep now until the launch, until this event. So yeah, we'll probably be tired a little bit. So guys, while you're registering to the webinar that is in 4 weeks time, let's answer some questions, shall we? So we have a few great questions in our Q&A, and a few questions are from Nick Smith. Do you have any examples showing the difference in design that results from a purely predictive design versus an on-site survey? So we have tons of examples like that, where we have assumed, based on the floor plan, the walls attenuation of, let's say, 3 dBs, because it looked like a drywall. But then you go on site and validate, and it's actually a drywall, brick drywall, a new type of partition that is not 3 dBs, that is 10 dBs. And that would change substantially the amount of APs that you put inside the premise. So it would take you, a day to go to the site and do a Wi-Fi design survey, and it would have saved you potentially hundreds or tens or several APs. That is way more expensive than spending a day on site validating attenuation of your walls. Another example, if you see glass buildings in big cities, you can see glass in most cases, and you can think that the glass is like 1 or 2 or 3 dBs attenuation, but in fact some glass is bomb-proof or RF-proof, and they might have 16 dBs of attenuation, and this will be a dramatic change to your design, because you won't be able to nicely cover anything through a thin glass partition. So I hope that answers your question, Nick. Another question is from Michael. I'm sorry, I don't fully understand what you mean by freezing the AP. Does that just mean keeping it in place before you move on? And that is exactly the case. When you do an AP on a stick survey and you have a physical access point on a stick, on a tripod, and you put it inside a room, and then you do a mini survey around it to, let's say, neg 85, preamble detect, signal detect threshold, then when you take this AP and you move it to a different location, it's the same AP, it has the same BSS ID, same MAC address. So when you start doing a mini survey around that AP, then Ekahau will think, oh, wait a minute, probably this access point is somewhere in the middle of between your initial mini survey and your second mini survey. If you don't freeze it, Ekahau will move this AP to a new location somewhere in between. If you freeze it, then you can use the same access point multiple times while doing multiple mini surveys as part of your pre-deployment AP on a stick validation survey. So I hope that answers that question as well. And I will answer one more question before we switch to Stu quickly. Any idea when Ekahau Pro will work on Surface X? And Surface X is ARM based, isn't it? Is it? Or is it just is it Intel? If it's ARM, then the answer is it will be a while because we don't have software that runs on it. If it's a Windows-based machine, then I was using Surface devices for years. I was using Surface Pros and I was using Surface Books with great success. Now, I wouldn't use them if I didn't have to. I would prefer to use it with my iPhone or my smaller iPad Pro with LiDAR and a pen input. That's what we are using today. So I hope it answers that question as well. Cool. Do we have any more answers, questions, guys?
Yeah, we had a really quick one just before we close out here. This is actually from Martin Suisse, where you talk about doing these AP on a stick surveys with extreme environments. And Extreme is known to have show duplicate MAC addresses for each of the SSIDs and the radios, and so this can be a challenge, right? And so the answer is yes, you can. And when you see the two different MAC addresses, you'll see two different APs, and you'll sometimes see this on Fortinet as well. We have a method to actually combine that later, so not to worry about it. You'll see your AP, you can freeze it. You can move it, pick it up afterwards, as Matt and Mac were talking about AP on stick survey earlier. When you come back into Ekahau Pro, we've got an algorithm that actually go ahead and fix that for you. So yes, you can do that. So it's important. So don't fret if you see that in your during your surveys. Not a problem. We can. The system is completely capable of identifying that.
Yeah, and then I see another question here asking about Survey being available for Android, and it's currently in beta testing at the moment.
Right. Yeah,
so,
that was the next one. Yeah.
Yeah, so it will be coming soon. So just stay tuned for that. We will have it ready for you soon. There was another question here about warehouse maps with very little reference points. What would be the best method? So what we used when we did the warehouse is we did use the autopilot survey mode, because that's fantastic. If you haven't got many reference points, you just find the ones when you first initially start, like grab somewhere that you are familiar with that you can line up with, like the door, the fire exit, a window, a pillar, or something that you can use. And then by doing the autopilot survey, when you haven't got references for where you can be tapping, that works so well for us, because you're just walking around and it's automatically drawing your path for you, which makes your life so much easier, so much faster. And again, in the warehouse, the big thing for us is that, we were no longer worried about getting hit by forklift trucks anymore, because we could have such a better awareness of our surroundings as we were moving around. So we would particularly go with the autopilot survey mode, but again, it will depend on your environment, what works best for you, if you need to use the stop and go or continuous mode for that. Was there any other questions in here before we wrap up today's webinar?
I think this is definitely had some really good points. Most of them were answered already throughout. So I think we're
good to go. Okay.
Really good to go. Yep.
Yeah, just want to say one more reminder. If you didn't see any of our previous Demystifying Wi-Fi series, make sure you go back and check them out, because when you piece all of them together, it will hopefully give you a really nice and clear understanding, and demystify Wi-Fi is what we were trying to achieve. And if it makes you hungry for more, that you need that more learning, then go and get yourself registered on one of our amazing ECSE courses. And then we will dive deeper over the course of 4 days, and you can really understand Wi-Fi comprehensively. So with that being said, we will wrap up today's webinar. Make sure you go register for the product launch on May 19th. It's going to be a big one. We're going to see you there and you're going to love it. I have 100% confidence that it's going to blow everybody's mind. So make sure you see you there. Thank you very much for joining us for the webinar and staying a few minutes over with us. We'll see you on the next one. Big love from me and Ekahau to everyone.
Thanks, guys.